So thank you everyone for coming in today. Hey, what I want to do today is take you through the steps that Novu took to be able to process 1 million notifications a minute. And through our journey, I hope everyone here today can take something away that helps your event-driven systems to become even more scalable than they are. So first, my name is Zac Clifton. I'm an enterprise, that's the old job. I'm a systems and application architect at Novu. I used to be an enterprise architect and platform engineer at Pennsylvania Power and Electric back in the States. I'm still in the States, by the way. And I'm a co-founder of my own bootstrap CS grader who aims to grade programming assignments at scale, but most and foremost, I'm an open source engineer. So who is Novu? Well, Novu is an open source notification, step away from that, platform that allows anyone with a little bit of coding experience to easily integrate notifications into their app and to be scaled to millions in the same day. So we've had a lot of really good achievements for the last 2 years we were founded. And one of the things I actually want to mention that's not on the slide is this month we've crossed the 31,000 GitHub star milestone, which means that we're in the top 400 public Git repositories out of 30 million. On top of that, we've processed over 30 billion events of notifications, and we support over 60 different notification providers, including one of your favorites. And the best part about us is since we're open source, if you don't have your favorite, make a pull request, add me at CliftonZ on GitHub, and I will absolutely help you facilitate getting it into the system so not only you can benefit, but everyone else in the community. So we process a lot of notifications, but how are we able to do this? Well, when we break it down to the smallest level, we keep it simple. One of the hardest things and one of the unique things about being open core is that I can't just go as an architect and say, let's use AWS Kinesis, because then that would totally remove the fact that we're open source. So everything we have to do has to be built on open source itself. So not only the big enterprise cloud users that send in hundreds of millions of notifications can use us, but also the person who just wants to host us on a little server. On top of that, we use a very proven and flexible tech stack that allows us to move fast and experiment. And there's two here I really want to highlight, and that is BullMQ, which is our message broker that we use to process jobs in our queue, and it's built on top of Redis, and Nest.js. And Nest.js actually saved our butt in one of the incidents that we had, and I'll be talking about later in this talk. But Nest.js is a progressive framework that has a lot of bells and whistles built in, and particularly it kind of pushes you to use clean code. So this way, you're already following good code practices just to use the system itself. So what makes us unique? Well, we don't just send notifications. We allow you to delay and digest. And this is where a lot of our complexity comes in. So delay, pretty simple. We're going to do a job later. But digest doesn't just mean we eat your notifications and take your money. So what it means is that in a window of notifications, we allow you to define a meaningful way to take all those notifications and make them something even better for your users. So they only get one notification. So instead of getting 100 emails, you're going to get one that lets the user notify what's the most important. Lets them know what's most important. And not only this, we actually offer multiple strategies of doing digest, where you can do the regular thing, which is what 96% of our users do, where in this window, digest. Or you can actually run a backoff strategy, which means that we're going to send a notification through, and then after that, we're going to digest after those. And it's great for monitoring situations when the system's down, and I don't want to get 1,000 emails because I know it's already down, but I want to get a digested notification so I know what actually is going on. And this is on our documentation page. I have the full architecture stuff out there, Eric, because that's what I think. That's what I believe in, that all this stuff should be transparent and open source. But now that you kind of know what we offer and what makes us unique, the road wasn't smooth. We had some lowlights, and we had some things that we were aware of, but unfortunately, we didn't catch in time, and we had a wake-up call. And really quick, I do want to mention that this part was the worst, intermittent 30 minutes delays, before I move on. Because as you most likely are aware, when you go hit a button to send a notification, you expect it to be on your phone last minute. Not the next minute, not 30 minutes from now, but as soon as you hit that button. And this was one of the worst things that we had to solve. So we had a wake-up call. Earlier this year, in June, we had our first official incident, and it took about 50% of our error budget for this year out. And it was due to our Redis instance being out of memory. So looking at what caused this, one of our top users went from sending about 30 requests per second all the way up to 400 and sustained that for about 30 minutes. And unfortunately, at the time, our system wasn't able to scale properly to handle this amount of load. And the cause of this was actually Bull and Q. The way Bull and Q works underneath the hood is that it sends a Lua script to Redis to add or remove a job. But Zach, if I having a queue, shouldn't I be able to add and remove it? We should, but that's one of the particularities of Bull and Q. While it's great for flexibility and it's easy to really implement, this is one of the biggest I think gripes I have to say about this, is that when your Redis system gets to the max, your system can't dequeue. And so this was something that we had to overcome. And unfortunately, as they say, anything that can go wrong will go wrong, and all at the same time. So this is actually the real picture of our CTO demo, working from the airport. And this is the recreation of me from AI. But that's the actual picture of him about to board a plane, helping me solve the issue of getting us back working. So we luckily had backups. We made a simple fix, and we octupled the size of our Redis queue. So we went from 12 gigabytes all the way to 128, so we can ensure that if anyone else went to that level again, we would have enough space. And luckily, the most amount we ever used was 16 gigabytes. So from here, this change wouldn't last. And as an architect, I wouldn't let it last. Not at all. It's not acceptable, because having a single Redis instance as our queue doesn't have enough resilience. And particularly when people are trying to send notifications to us, and those mean a lot, particularly in bad situations, we can't have that. So we had to move to a Redis cluster. But we couldn't just move to any Redis cluster. Because when you go to a Redis cluster that has backups, even if I'm taking backups at a 1-minute interval, that's still not enough for us. Because in between those minutes, I could have spikes of thousands or millions of triggers, and that would lose precious notifications. So we had to move to a Redis system that supported a pinned-only log file, which means that per every write I write to that cluster, it writes it to a multi-zone transaction log. And in AWS, the only option to do this is MemoryDB. So what this allows us to do is that even if the primary goes down, any of the other replicas in any shard can then pull the transaction log, get to the current state, and become the new master to start continuing to write. So, but there was one catch to this. Bull and Q doesn't fully support Redis clusters. And the reason for that is when you run a Lua script and add a particular key to a cluster, it doesn't guarantee it's on the same shard. So we had to work around that by adding a hashtag to our queues. And once they're created, they're basically stuck in that slot. So we just made a simple script to create a set of 6 characters that uniquely identified our queues, so that way they could each land on their own shard. So we solved the queue problem, but unfortunately, we still saw when these power users, and it's actually the same one, notice the same color here, it's the same one, whenever they would have spikes, we would see this major backlog of messages. So we were like, okay, well, we got the resiliency problem gone, but we need to figure out what's causing these backlogs, right? We need to have notifications out yesterday. So when we looked at our architecture, and I had already architected this out, we found that, oh, wait, why is our event processing on the same level as our API? And so we thought, oh, it's just that we don't have enough processing power. So we just made the simple change to take the worker and make it its own service. This way, we can scale the API and worker independently. And luckily, this was an easy change. This is actually one of the easiest production changes we've made so far because of Nest.js already putting our code in clean architecture, where we were following clean use cases and clean strategies. So all we had to do was pull those strategies out, put them in a new service, and deploy them with our Terraform script. Done. Super simple, super easy. So before I get into the real reason why we were having this, because this actually wasn't the real reason, I want to show actually why we needed to have these separated. And while it is common practice, for us, one trigger to send doesn't equal one notification sent. In Novu, when I send a trigger, what that does is it triggers off a workflow. And that workflow can have many different subscribers in it, whether it be a certain subset or all of your subscribers in your organization. Each one of those subscribers get their own job. And not only that, each one of those subscriber jobs then gets its own set of jobs for every node in the workflow. So when I did the analytics for this talk, what we saw was that most users only have about 3 nodes in their workflow. But the common user generates around 1,600 events. Okay, that's not too bad. But our power users, and this is an average, right? So we have people doing much more than this, can generate on average 6 million events per trigger, right? And our power users are sending somewhere between 4 and 5 or even more requests per second. So we're generating a lot of events based on just simple usage of our system. And not only that, over the next 1 to 2 years, we're going to be generating even more with some of our new features that we have on our roadmap, particularly the decision trees. So we thought a problem was solved. We're able to scale the system where we can just add as much compute as we needed. But even though we added as much compute as we needed, we were still seeing backlogs of messages. And this was because we were hitting a problem known as the head of the line problem. So if you look at our queue flow, and again, this is all publicly available, you're able to go see this yourself. You can see that as we have a trigger, we go for each step, we hit the trigger queue, we fan out for the subscribers, we fan out for the jobs, then we do the job processing where that actually sends the notifications, and sometimes if we need to, goes back into the queue. But what the head of the line problem is imagine each one of these colors as a company, and each one of these boxes as 1 million triggers. So if the red company over here puts in 1 million triggers, I can't process the blue companies until I process all the reds. And same for the yellow. I can't process yellow until I process blue and red. And this becomes even worse if you think about all these as 2-factor, right? We're all in a really quick window. This is not acceptable in the fact that yellow has to wait for all of their 2FAs to go after red. So when you look at the head of the line problem, this is particular for queuing. What it really is a symptom of is starvation. And starvation means that we're perpetually, in some way, denying access to the right piece of work at the right time. And if you look even deeper, we're actually suffering from a very specific problem called job starvation. So it's not just that we're not denying it at the right time, it's actually in the queues, we're having an excess amount of jobs. And that's due to the fact that we can't get down to 0, our ideal state, fast enough and in the right way. So the way you can think about job starvation is the underlying layer of job starvation is really that there's no mediator. There's nothing telling the consumers how to process this correctly. You can imagine that if you were to be hired into the warehouse, right? So we have thousands of boxes that we have to process. You come to me on your first day and say, how should I process this? And I say, it doesn't matter. Okay, so then you're just gonna start grabbing things and processing, right? You come to me the second day and you say, look, there's gotta be a better way. And I'm like, okay, I think there's a better way. Take every box that ends in 5 and process those first. Okay, so now you have a better idea. You can go search, you can go grab exactly the box you need, and once all of the boxes that end in 5 are done, we can go to move on to something else. But that strategy of ending in 5 may not be the best one every single day. So now we have to go back to talk to me every day to figure out exactly which way to do it is right. And even in the day, it may change. So if you think about it even farther, the best way we could do this is that I just sit here at a desk and you give me the piece of the work that I need to work on. It's the same thing with job starvation. And the only way to change this is you actually have to change the architecture of your queue. And the way I just described this, right, having no direction, some direction, and it's fully decided for you, is the same thing with our queue architecture. So single queue, multi-queue, dynamic queue, right? So this is how we had to change our system. Now, we haven't got all the way to dynamic queue yet, but we did make steps towards doing a multi-queue. And when we first took a look at this, we first thought, like most people, we're going to do a hierarchical multi-queue, which means that per job step, we're going to have 4 queues per that queue step. So we have a critical, high, medium, and low. Or you can think about it as 2FA, enterprise, business, and free. But when you take a small step back and say, okay, well now I'm going to have company A and company B send their 2 factors. They go into critical, and now I still have to, process all of company A's before I can get to company B. Crap. So, was it the right step? No. And if you take anything from this talk, I hope that you take do not do a hierarchical multi-queue. It is almost always not the right choice because you're only introducing more complexity for the same amount of the head of line problem. So the better way to solve this is you do a queue per your lowest granularity. For us, that was workflows. So in Novu, we have organization, project, environment, like dev or prod, and then the individual workflow. So each one of those workflows get their own queue. And this way, our workers can just round robin pull each queue so all of the processing happens equally. Now, for the most astute of you, you'd be like, well, what if I'm sending the same workflow over and over? Yeah, you're getting into the head of line problem again too, unfortunately. And so for us, this will be a temporary fix. This is going to get us for there for a while, and we've done some things to extend it, which I'll talk about in a minute. But realistically, for most of our systems that aren't going to process the amount that Novu's doing, our North Star company currently this year is called Braze. So North Star, I mean the one that we look at in terms of our niche that we should architect for. They're currently, as of this year, sending 10 trillion notifications a month. We're not there yet, but if we're going to get there, we can't stay with the multi-queue. But for most systems, a multi-queue will work quite well, and it'll get you quite far. So for us, what we'll be doing over the next year or two is moving to a dynamic queue, which basically has a mediator that tells the workers exactly what to do and exactly which queue to process from. Now, talking about dynamic queues and different architectures, that can be its own talk itself, but this is the simplistic way to implement dynamic queue and the one that we're going to start out with. So that begs the question, well, okay, Zach, I've now migrated to a multi-queue structure, and I want to make sure that I never have to touch dynamic queue because that's too complex. It's not worth the money for us. We won't get to that scale. Well, what can I do to extend that life? So that way this can last us the life of the company or many years at most. Well, the first thing that you should think about is adaptively scaling your workers. And what I mean by that is setting a SLA to say how long should a full queue take to process. For us, that's 30 seconds, right? A notification needs to be here now. We don't have a choice on that. That's told us by our customers. Now, if you're in a long-running job system, different story. That could be 6 hours, that could be a whole week, but for us, it's a much lower level. And so our first step that we did, now this piece of pseudocode does not cover periodicity, seasonality, scaling freezes, predictive scaling, anything like that. This is literally, and I hope if you are going to implement this, use this code. I hope you do. Because all it does is it just looks at the delta between the number of jobs in the queue and how much we can currently process and scale up or down based on that. It's a simple Lambda function, and it's very easy to do to get you started. Now, the more complex stuff, that's going to take some time, but at least this gets you started. The second thing to extend your multi-queue is create a time to live. Most messages have a lifetime. They start, they're in flight, and they either end or they're canceled. And when you go to send a notification for us, we have to ask the question, what happens if Google's down? Well, realistically, they're not, but what happens, right? They have a set of error budget just like us, even though it's milliseconds, but what happens if we can't send a message in that millisecond? So we need to set a time to live, so that way a message is never just infinitely in our queue, right? We don't want our queue just scaling as much as we can because Redis has a hard limit on the amount of memory it has. So for us, we set a time to live, and that a message is only going to last, depending on the situation, 24 to 72 hours. This allows us to ensure that when messages have their end of life, we can just notify the user, and we can keep our system stable for the long run. And lastly, we create meaningful funnels. And in this way, what we're doing is we're implementing rate limiting and load shedding. So I need to stay away from that speaker because it's going to be mad at me. But rate limiting is pretty simple. You can only send so many triggers per second. But one of the things that we also have to think about is what happens if our system is already at the max and we can't process much more, even though people are staying in their limits on their rate limiting. So that's where we would implement load shedding. So we would say to a certain percent of requests that coming in, hey, I need you to retry in 1 minute. So this way we can process everything we need before we move on to the next piece. So through all of this, there was a few key pieces that I really want to share with you. In the fact that if this had been a part of our process ahead of time, we would have caught this and we would have made it much more of a priority. And the first thing is know your scale. Like I said earlier in the talk, we have a North Star. I'm an architect by trade, and one of the things that I always do when I architect a system is look at the niche that we're in. What company is reaching what scale? What things did they fail at? What talks did they do? If you're making a notification company, use this talk to help yourself out. And you can tell by those people in that same niche what scale you're going to get to and what problems you're going to have. And because of that, it gives you a leg up in saying, hey, CEO, we're going to have this issue at this scale, and it's predicted to be here in 3 months. What are we going to do about it? And then you can come back to this and say, hey, here's what we can do. So know your scale. Know what you're expected to hit and what you're doing. Doesn't mean you have to implement it now, but at least be prepared. Next thing, it ties into this of knowing your scale, is do some research. And if you're not great at it, hire an architect, hire someone that is good at it, a senior dev, so they can assist you in not having to stall your company in 2 years from now, because that's not what you want at all. You want to be able to continue growing and adapting to the market. For example, the head of the line problem was not solved by us. We might be good, but we're not that good. It was actually first solved in the CPU. And that's where the first set of job scheduling started to happen. And so you can simply look at a lot of hardware things that have happened in the past. A lot of the stuff with the cloud you see today is things that have already happened in the mainframe world. It's just we weren't around to see it. And so not only that, when you know your scale and you've done your research, you now have a really good, accurate representation of how you should stress your system. This is one of the things we failed at in the beginning. While we would run tests locally, we didn't really put a production live system out there and really throw it. We had it, but we just didn't really push it to its limits. And now one of the things that we're looking to change is this, is that we know that the product is the answer. It's the right questions we got to push at it. And so one of the things that we're working to do now is to be able to stress the system to be 2 times our expected amount. This way, that even if I'm expected to grow to 10 million or even 200 million or 1 billion notifications by next year, we're already testing the system to ensure that it'll keep up and keep within the limits that we set. So that way your notifications get there on time. So I really appreciate everyone being here today. I'm happy to talk about architecture. I'm happy to help you. Feel free to reach out. This link here, it goes to our documentation where you can check out on how to add, if you want to add notifications to your app quickly and easy. It has all of our quick starts, and it has all of our architecture documentation that I personally make sure is up to date on there. So you can see how we have the system set up to help your systems too. So thank you, and until our paths meet again.
Okay, any questions?
Thanks a lot for amazing talk. Just for me to know, what kind of observability stack you use to make sure you follow the service level agreements? And
Yeah.
what are the key indicators also?
Great question. So for us, we use New Relic currently. However, because of the amount of scale that we have, we don't necessarily see just like a constant load. What we see is what's called a hybrid load. So we have not only a constant amount, but we actually have peaks. So you get this kind of sinusoidal happening with terms of periodicity and just like marketing campaigns for like Black Friday and stuff. So for us, adaptively scaling is extremely important, and we need a system that can support that. So we're actually going to be moving soon to Kubernetes, where we'll have the looks good to me stack, Grafana, Prometheus, Loki, Tempo, to do that in the future. And a lot of our key metrics are around how many triggers are being sent, so how many people are using the system. And the other key metric is how quick do those notifications get to you, right? So at some level of scale, can it get to you in less than 30 seconds? So those are the key indicators and the platforms that we use and will be using to support that.
Thank you.
You're welcome.
Other questions? Well, there are no questions. Let me ask you a question. What was the reason why did you choose Redis for queue management instead of, let's say, RabbitMQ or SQS or any other solution?
Amazing question. So the reason why we did that was before my time. It was actually part of the original thing. So BullMQ natively integrates with TypeScript. And it's really easy to get up and going and running to our level of scale, but it does have resiliency issues. So one of the things that I'm looking at doing is moving off of BullMQ in the long run to Pulsar, which, if any of you are not familiar with, Pulsar is like Kafka 2.0. So Kafka is really great for streaming. It's a streaming platform, but a lot of issues with Kafka come in when I'm trying to operate it at an extremely large scale in multiple geographical regions. I'm trying to ensure that data is offset to cold storage, and I want to be able to scale correctly. So Kafka natively doesn't support geosynchronous. So you have to use Mirror Maker to be able to say, oh, this cluster is in sync with this cluster. That's a really hard thing, especially since for us, we want to eventually get to the point where we have globally deployed systems where no matter where you trigger from, it's always going to get to our user the quickest, right? So we'd be able to say, if you're in Asia, it doesn't take 30 seconds, it sends right from Asia. The second part about that is scalability. Kafka, whenever you add a piece to it, what it does is it has to rebalance the whole cluster. And for us, we can't afford that level of rebalancing, especially at peak loads. So those two things are really the biggest pieces of why we want to move to Pulsar, though it's much more edge. It's not as, familiar to people as Kafka. But on the bright side, Pulsar can actually run the Kafka protocol on it. So once we get to that place, then we can just simply migrate and add support for other things in the future in terms of streaming.
But still, why not RabbitMQ, which is pretty standard for such a task?
So another great question. So when you look at a lot of the architectural stuff between a streaming platform and a message broker, one of the things, the message broker is essentially a streaming processor, but with more wheels enabled. So it's easier to use. It's much, it gives you routing, it gives you a lot of stuff on top of it. But what happens is the scalability of a message broker, right? So ActiveMQ, RabbitMQ, that kind of stuff doesn't scale as well as a streaming processor because it has those bells and whistles built in. And the reason for that is because it routes everything in memory. And so as I scale my message brokers, I have to have more and more memory. Google did a good study, I don't have it anywhere here, where they were able to have RabbitMQ send 1 million messages a second, but it required some of their biggest servers, and it required a cluster, I think, of around, it was 30 plus. But when you look at that and compared it to something like Pulsar and Kafka, it can handle it in a simple 3-node cluster. And while you have this trade-off of, okay, it's simple to use over here, but it's hard to scale, using Pulsar Kafka streaming processors allows you to scale at a much higher rate, much faster, but as the cost of you add extra complexity to your system. Because with a streaming platform, you don't just get the routing, the priority all built into it. You have to be able to, per se, build that yourself. Like with Kafka, Kafka doesn't support delay, so I'd have to build the whole timing wheel mechanism and storage, whereas Pulsar, for example, supports delay. So that's one of the biggest things of why we don't want to go for a message broker versus a streaming platform. It's because at our scale, a message broker is going to, frankly, put us out of business in 3 months compared to a streaming processor.
Okay. Any more questions? Okay, then thank you again.
Yeah, no problem.